Hello there, this is Casey and I'm going to discuss to you the first two lessons of Appendix 6, Electronic Spreadsheet Summary of Built-in Financial Functions, which is C.1, that is nominal versus effective interest rates, and C.2, which is single-sum compounding functions. This tutorial will demonstrate how to use Excel's financial function to handle basic time value of money problems using the same example in some tutorials. Excel is the greatest financial calculator ever made. There is more of learning curve than a regular financial calculator, but it is more powerful. Let us discuss first C.1, nominal versus effective interest rates. This will let you know that Excel functions can easily calculate the effective interest rate to a nominal interest rate or vice versa. On this page, you will see the effect and nominal function in Excel. The syntax for both functions is as follows. To find the effective nominal rate, just type equals effect, open parenthesis nominal, underscore rate, comma, and peri, close parenthesis. And to find the nominal interest rate, you are going to type nominal, open parenthesis, effect, underscore rate, comma, and peri, close parenthesis, wherein and peri is the number of compounding periods per year. Effect underscore rate is the effective interest rate, and nominal underscore rate is the nominal interest rate. Let's proceed into some examples. So we have here two examples. For the sample one, we are going to find the effective interest rate, wherein there is a given nominal rate of 10.75 and end peri, which is 87. We are going to enter the formula, which is effect, the nominal rate, comma, the end peri. As we enter, we are going to find 0.113417 or 11.34%. For the sample 2, we are going to find nominal interest rate, wherein we have a given effective interest rate which is 9.87% and end peri which is 87. So we are going to type the formula here. Nominal, don't enter when you are typing the formula. Nominal, then the effect rate which is 9.87, then 87. Upon entering, we ended up 0.09 for the nominal interest rate, or simply 9.41%. See, as easy as that. Now, we are going to proceed in the next lesson, which is C.2. In this next lesson, C.2, I'll discuss the single compound function using the Microsoft Excel. The single sum compounding functions deal with either the single payment compound amount factor or the present worth factor. With these functions, the future amount when the single sum is given, present amount when its future amount is specified, or a known interest rate, and number of interest periods can be computed. Okay, we'll begin first in calculating the future worth of a single payment. And here is the syntax that we are going to enter. Equals FB, open parenthesis I, comma, N, comma, 0, comma, P, close parenthesis, where I is equals to the rate of interest, N is the number of periods, and P is the present value. We'll begin with a very simple problem that will provide you with the most of the skills to perform financial math using Microsoft Excel. And here's the problem. Suppose that you have $100 to invest for a period of 5 years at an interest rate of 10% per year. How much will accumulate at the end of this time period? In this problem, we have a present value of $100, years is 5, and annual rate is 10%. So we are going to type here for the future value FP, then the rate, the years, 0, we make the present value negative. And so we ended up with the future value of $161.05. And so we have a future worth of $161.05. Next, we are going to calculate the present worth of a single payment with a syntax of equals PV, open parenthesis, I, comma, N, comma, 0, comma, F, and close parenthesis, where I is the rate of interest, N is the number of periods, F is equals to future value. Solving for the present value of a lump sum is nearly identical to solving for the future value, except that we use the PV function. One important thing to remember is that the present value will always, unless the interest rate is negative, be less than the future value. Keep that in mind because it can help you to spot incorrect answers due to a wrong input. Let's try a new problem. Suppose that you are planning to send your daughter to college in 18 years. Furthermore, assume that you have determined that you will need $100,000 at that time in order to pay for tuition, room and board, party supplies, etc. If you believe that you can earn an average annual rate of return of 8% per year, how much would you need to invest today as a lump sum to achieve your goal? In this case, we have a given future value is equals to $100,000, years is equals to 18, and annual rate with 8%. And we are going to type the syntax here, equals PV, the rate, comma, the years, comma, 0, comma, and negative future value. So we're going to enter. Now, we got a present value of $25,204.90. And that's the answer. Now let's proceed in solving for the number of periods with the syntax of equals rate, open parenthesis, N, comma, 0, comma, P, comma, F, close parenthesis. N is equals to number of periods, P is the present value, and F is future value. Sometimes you know how much money you have now and how much you need to have at an undetermined future time period. If you know the interest rate, then you can solve for the amount of time that will take you for the present value to grow to the future value by solving for N. Let's have this problem. Suppose that you have $1,250 today and you would like to know how long it will take to double your money to $2,500. Assume that you can earn 9% per year on your investment. In this problem, we have a present value of $1,250 and the corresponding future value of $2,500. We have also an annual rate of 9%. However, our payment period is unknown and we are going to find that. We are going to enter N equals to the rate, comma, 0, comma, the future value, the present value first, then the future value. Notice that we got this error. We got this error because if you don't make either the present value or the future value a negative number and the other one positive, then the error occurred. That is because if both numbers are positive, Excel thinks that you are getting a benefit without making an investment. If you get this error, just fix the problem by changing the sign of either PV or FV. In this problem, it doesn't matter which one is negative. The key is that they must have an opposite sign. So let's try to make the future value negative. And so, this is the real answer. The payment periods is 8.04 years, or simply 8 years. So we now go into our last topic for this video, which is finding the unknown interest rate. So we are going to use the syntax equals rate, open parenthesis, n, comma, 0, comma, p, comma, f, with a close parenthesis, wherein n is equals to the number of periods, p is equals to the present value, and f is equals to the future value. Solving for the interest rate is quite common. Maybe you have recently sold an investment and would like to know what your compound average annual rate of return was. Or perhaps you are thinking of making an investment and you would like to know what the rate of return you need to earn to reach a certain future value. Let's return to our college savings problem from the first two problems above. Or for the first two problems that we first solved, but we'll change it slightly. And here's the problem. Suppose that you are planning to send your daughter to college in 18 years. Furthermore, assume that you have determined that you will need $100,000. At the same time, in order to pay for tuition, room and board, party supplies, etc., if you have $20,000 to invest today, what compound average annual rate of return do you need to earn in order to reach your goal? So, for our last problem, we have a present value which is $20,000, a future value which is $100,000, and a year of 18. So we are going to find what the interest rate is. As before, we need to be careful when entering the present value and future value into the function. In this case, you are going to invest a $20,000 today, it is a cash outflow, and receive $100,000 in 18 years, which is a cash inflow. Therefore, we entered negative $20,000 for the present value and $100 into future value. Again, if you get error instead of an answer, it is because you didn't follow the cash flow sign convention. So we are going to enter rate, then the year, then 0, then we're going to make the present value negative, then a positive value for the future value. And so, we computed a total interest rate which is 9%, and this is the final answer. Well, just a few reminders. When you have solved a problem, always be sure to give the answer a second look and be sure that it seems likely to be correct. This requires that you understand the calculations that the functions are doing, the relationships between the variables. If you don't, you will quickly learn that if you enter wrong numbers, you will get wrong answers too. And lastly, Excel only knows what you tell it. It doesn't know what you really meant. And so, this ended my video, and this has been Katrina Santos, and this is my third video for engineering economy. Hope that you learned something, and see you in my last video.